Hello everyone, today I am going to solve this problem. Please pause this video and read this problem very carefully. In this problem, we have to find the initial acceleration of this box. As per the problem, the tension T is given as 23 Newton and 26 Newton for two cases. So we will solve for both cases. I will write the important information which is given in this problem, such as the tension is 23 Newton and 26 Newton. The mass of this block is 15 kilogram and we have to find the initial acceleration. Mind it that the box or block is in the rest condition. It means there is no velocity, no acceleration at starting or at the beginning when the force is applied. We also assume that there is no slack in the cable. It means that cable is not loose. Now we will solve this problem by solving or making free body diagram. Now let's see how to make free body diagram. First I will make a box or block on the surface, and as per this problem there is a friction on the surface and there is a kinetic friction and the static friction is given. So first of all we create normal force which always acts perpendicular to the contact surface. Then I will make the mg which is working in the downward direction. Now I will create the tension T force which is given in the problem at 30 degree. So this T is from the cable. Now you can see here that there are two more cables which is connected to another point. So when we are solving this kind of problem where there is a cable, we use or we make always one force working in one cable. So here you can see there is a two cables, so I made 2T here. And there is a friction force, so we assume that friction force is working in the left side. Okay, so till now we do not know in which direction this block will move, but as per this picture we assume that this block is going to move in the right side because there is a tension is applied. Okay, so but I don't make any assumption. We solve this problem by using x and y axes, and what will be the result, then we will determine the motion of this block. Now second step is here. We will write all force equation. It means that we will make equilibrium of the forces, or we will balance the forces in x and y direction. So look here, I made the positive x direction in the right side and positive y direction in upward direction. This is our assumption and this is the most convenient way of choosing the axes. So let's balance the forces in x direction and in the y direction. So let's start with the x direction. Also in this problem, the static friction and kinetic friction is given. So we will assume that this block is in static equilibrium. This is just our assumption before solving this problem. It means, in simple way, that we will assume that this block is not moving, it is just stationary, and the all forces are working on it are in the balance. Okay, it means that all forces are equal on the left side or right side or Let's go to free body diagram and see what are the forces working in x direction. We also assume that this is a equilibrium condition, so we will write Fx is equal to 0. In this free body diagram, you can see that friction force is working in negative x direction. And there are two T on the right side that is working in positive x direction, and there is also T on which having 30-degree inclination, so we will also use that component. So I'm writing here minus F plus 2T, and the component of that T which is inclined, T cos 30, is equal to 0. So just for reminder here that there are three different forces are working, okay, in x direction. Similarly, we will also balance the forces in y direction. In y direction, there are fewer forces, and it is very clear from the free body diagram. Let's see here. There is a normal force working towards the positive y direction. Okay. The second is the mg, which is working in vertical downward direction. And third will be the component of T, tension T in y direction. So let's write all three forces in y direction. And as we have assumed that this is a equilibrium, static equilibrium condition, so Fy is equal to 0. So I wrote here n in n plus t sine 30 is equal to mg. Mg is working in downward direction, and other two, n and t sine 30, is working in positive y direction. So guys, we have now two equations, one in x direction and another one in y direction. Now we will go back to the problem, and in this problem they ask us to solve for two conditions when tension T is 23 Newton and when tension T is 26 Newton. Now you can evaluate both equations by putting the value of tension 23 Newton in the equation 1 and then in the equation 2. In both equations, there are two unknowns. One is force F and there is another N normal. By simply calculating both equations, the value for F is 65.9 Newton and the normal force is 135.6 Newton. This is the case for first condition when tension is 23 Newton. Now, as per this problem, the static friction is given to us. So our first focus is to know that this box will move or not. This will tell, or we can find it by using Fmax. So force maximum is equal to static friction multiplied by normal force. So here we have put the value 0.5 multiplied by 135.6, and we found that F max is greater than F. So our F is 65.9, which is lower than the maximum force. It means that box will not move. We need at least 67.8 Newton force to move this box or block. So we need higher value for moving this box. It means we need more tension in the cable. And when this box is not moving, it means the acceleration of this box is 0, velocity of this box is 0. So from the first condition, we are sure that box is not moving because F max value is higher than the whatever the force we have calculated. So we will go for the condition 2, where the tension in the cable is 26 Newton, and we will check out again in the same way that box or block will move or not. So our assumption for static equilibrium is right. It means static equilibrium, we wrote that Fx is equal to 0 and the Fy was 0, right? So it means that the box or block is on the surface and it is not moving because of the static friction. Now let's solve for the condition second. Okay, here we will use the value of tension in the cable as 26 Newton, and we will repeat this problem by using the equation 1 and equation 2. So you can solve it by simply putting this value t in the equation 1 and in the equation 2. Here is equation, and you can put the values. Now after calculation, the values are shown on the screen. The value for force F is 74 Newton and normal force is 134.2 Newton. This answer is received by using the value T is equal to 26 Newton. Now our job is again to check that this block will move or not. How we can do it? By using static friction factor. Okay, so we will use F max is equal to static friction coefficient multiplied by normal force. So 0.5 multiplied by 134.2 Newton. So here you can see that F max is 67.1 Newton, which is lesser than the F. So it means that block will move now. Why? Here it is very simple. That maximum force required to move this block was 67.1 Newton. But after applying T is equal to 26 Newton K in the cable, the force which we have calculated is higher, F. So it means that block is now moving. And at this moment, I cannot say that block is moving in positive x direction or negative x direction, or simply in the right direction or in the left direction. Okay, so we will calculate acceleration, and from that acceleration we can know in which direction this block is moving. Also, it means that when block is moving, it is not in the static equilibrium condition. Okay. Since we came to know that block will move, we will take help from the kinetic friction coefficient to know the exact value of the F. So how we can calculate? F is equal to kinetic friction coefficient multiplied by normal force, and thus we received the value is F is equal to 53.7 Newton. Now guys, we will use this value for the F in the equation 1 and the equation 2, but with a slight change. Previously we were assuming in the equation 1 and 2 that block was not moving, it was in the static equilibrium. So I'm going to use this F in the equation 1. Why? Because we need to know in which direction the block will move. In x direction, of course. So I can write Fx is equal to max. Now make sure that this Fx is equal to not 0. Why? Because it is moving and there is acceleration ax, and there is no acceleration ay. Okay, it means that block is not moving in the y direction. We will say that okay, ay is 0, so ax is equal to a. Now balance all forces in x direction, and it was very simple. We have already written on the right side we can say max is equal to ma. Now your job is to put the value for the F. You just calculated here 53.7 Newton plus 2 multiplied by 26 Newton plus the component of T in x direction. Okay, why? Because we are solving in the x direction, is equal to ma. The mass of this block is 15. So now from this equation we can simply calculate the acceleration, which is 1.390 meter per second square. What is important here? It is plus. the value for acceleration we got is plus. It means that block is moving in plus x direction. So you can go back to the free body diagram and see what was our assumption for the x. So here x is in the positive, x is in the right direction. Okay, so it means this block will move in the right side or plus x direction. I hope you have understood it very well. If you have any question, you can write in the comment section. And if you have any other problem from the dynamics, you can also let me know. Thank you very much. Don't forget to subscribe and like this video. Have a nice time. Have a great day. Thank you very much.